Another one is a network or the network models. These are models where large, complex tasks are broken into smaller segments that can be managed independently. This will allow you to distribute the tasks in one from large, complex task to different teams, different groups for easy monitoring and control. There are two prominent models. One is the program evaluation review technique, and this is a technique which enables engineer managers to schedule, monitor, control large and complex projects by employing the three time estimates for each activity. Another prominent model is the critical path method. It's a technique using a one-time factor per activity that enables engineer managers to schedule, monitor, and control large and complex projects. So this is an example of a PERT CPM chart. The circles here are the milestones or the checkpoints for your activity. So the activity here is the development of a PC card. So number 1 is the start of the project, and number 11 is the project completion. The arrows between circles are the path that you take. That means the dependency of each task. That means number 3 and number 4 are all dependent in on number 2. If number 2 is not done, then number 3 and number 4 cannot proceed, as well as number 6. So you have here number 1, start of the project. For 6 weeks, you're going to formalize the specifications, and then by after 6 weeks, you should have a uh, finalized specs. So the red here are the critical path. That means one delay in any of these checkpoints or any of these activities will cause a significant delay in project completion. For example, if number 2, between 2 and 3, this will not be completed in 4 weeks. That means you will have to you will have to reevaluate this again, and that will cause significant delay in the breadboard hardware, as well as the testing of hardware and the releasing of hardware. So this is critical path method. This is used for monitoring and scheduling of large complex projects. Number 4, forecasting. There are instances when engineer managers make decisions that will have implications in the future. For example, a production or manufacturing firm must have a capacity which is sufficient to produce the demand requirements of customers for the next 12 months. As such, manpower and facilities must be acquired before the start of operations. To be able to make an effective decision on the capacity, the engineer manager must be provided with data on the demand requirements for the next 12 months. So this is in the future. So this type of information may be derived through forecasting. So forecasting is defined as the collection of past and current information to make predictions about the future. Next, we have regression analysis. A regression model is a forecasting method that examines the association between two or more variables. It uses data from previous periods to predict future events. Regression analysis may be simple or multiple depending on the number of independent variables. So if you have one independent variable, It's called simple regression. If you have two or more independent variables, then it is called multiple regression. And regression analysis, as used in forecasting method, is also used as a foundation for machine learning, especially for prediction algorithm. Next is simulation. A simulation is a model constructed to represent reality, where conclusions about real life problems can be used. It is a highly sophisticated tool by means of which the decision maker develops a mathematical model of the system under consideration. The simulation, though, does not guarantee an optimum solution, but it can evaluate the alternatives fed into the process by the decision maker. So it's using uh, science and mathematics to evaluate the different alternatives that you can use to address a problem. Next is linear programming. It's a quantitative technique that is used to produce an optimum solution within the bounds imposed by constraints upon the decision. So linear programming is very useful as a decision making tool when supply and demand limitations at uh, manufacturing plants, warehouse, or market areas are constraints upon the system. Another one is sampling theory. Sampling theory is a quantitative technique where samples of populations are statistically determined to be used for a number of processes, such as quality control and marketing research. So, when data gathering is expensive, sampling provides an alternative. Sampling, in effect, saves time and money. So one basic example of sampling theory is the survey conducted by different groups, for example, the SWS survey. So they don't ask everyone in a particular area, but they only get a sample of the population. So there's a mathematical formula or statistical formula to determine how many of this member of the population can represent the entire population. Okay, the last one is the statistical decision theory. Decision theory refers to the rational way of conceptualizing, analyzing, and solving problems in situations involving limited or partial information about decision environment. Earlier in our discussion, uh, we discussed evaluation of alternatives. Now, one important component in decision theory, especially in the evaluation of alternatives, is subjecting the alternatives to the Bayesian analysis. The purpose of the Bayesian analysis is to revise and update the initial assessments of the event probabilities generated by the alternative solutions. So this is achieved by the use of additional information. When the decision maker is able to assign probabilistic probabilities to the various events, the use of probabilistic decision rule called the Bayes criterion becomes possible. The Bayes criterion selects the decision alternative having the maximum expected payoff or the minimum expected loss if he is working with a loss table. So in this lesson, we learned that decision making is a very important function and responsibility of the engineer manager. We also learned the process of coming up with sound decision and using qualitative and quantitative models as approaches in solving problems.